Alright guys, let's start the problems on the matrices and determinants. The first problem that's coming to you for type 1 and type 2, which is matrix addition, subtraction and multiplication over here. These two problems will solve, okay, for this paper. And I've extracted all the problems just for these two categories. So don't worry about the ones in the grays. Let's take this first problem, summer 2019, 4 marks. There is a matrix that is given and you have to find or compute a square minus 8a. And interestingly enough, the same problem has been given in winter 2018, question number 4a for 4 marks, where it's the same problem, but instead of saying find, they are saying that show that a square minus 8a is a scalar matrix. And like I said, this if I were just given this is a problem for me. I would avoid this, and this is a great example for me because the answer is given. I need to show that. That means I know that whatever I'm computing, it has to fit into a scalar matrix for the answer to be right and to secure my 4 marks, right? So I'll take both the problems and I'll apply it and solve it for you, and you can understand how that goes. Primarily, this is going to be a type 1 problem because this is heavy on multiplication. Both these problems are type 1. Oh, sorry, type 2. Sorry, type 2. My bad. Type 2 because it's heavy on multiplication. It has some addition and subtraction in between, but primarily it's a type 2 matrix multiplication problem, which will be the case in most of the matrices, which will be type 2. There'll be hardly anyone which is pure play type 1. I think there's one problem at the end. We'll come to that when we do it. But this is a type 2 problem, pure play matrix multiplication. And let's get started. Okay. So I've copied both the problems in the exact words for the benefit. And like I said, some of these things are repetition, but just a friendly reminder. This kind of problems could be, this one in specific could be a student-friendly problem because the answer or the end result is given. So we can't go wrong in this. Okay. So always attack those problems where you have been asked to do the LHS is equal to RHS or the solution is already given, which is in this case, again, not in this case. This is good to go. And in any problem, whether matrices or determinants or any mathematical problem, always read the question very carefully, slowly, word by word, at least 2 to 3 times to understand what is given. You'll be able to break it in your head if you practice well to relate what kind of problem or what type it fits into. In this case, we know that this is going to be a type 2, but you have to slowly and patiently read. You have to see, okay, what are the hints given? A square minus 8a. Okay, I know this is a matrix problem because the braces are closed here. That's a matrix. And I know that they're talking about a square minus 8a. So it looks like there is a multiplication here. So I know it's a type 2 problem, right? And then let's see what other hints are given. In this case, they're clearly calling it that show that it's a scalar matrix, right? So if you know that, even if it's not given, just the number 8a means that the matrix A is going to be scaled by number 8. So we still know that there is some sort of scalar here going on. But in this case, they have clearly called out that show that this whole computation is a scalar matrix. So we know that that's the biggest hint that it's a scalar matrix. So the first thing that you do is, okay, I read that, I know that I need to prove that, I love this problem. And the first thing you draw on the side or on a rough note or wherever you have is, okay, what is a scalar matrix? A scalar matrix is something where the diagonal elements are going to be the same and everything else is going to be 0, right? Or something of that sort. So you know that that's how it's going to be. So that's a scalar matrix. The number has to be the same across on the diagonal and everything else has to be 0. Then only it becomes a scalar matrix, right? You know that. So just make a sketch of that on the right. Do all the check boxes. And just a word of caution. Matrices are normally lengthy and too much of computation. It can just be overwhelming and you might just get fatigued solving the problems and you might pick up the wrong row and the wrong column, right? So the thing that I put in red, that's a caution. Calculation mistake is highly likely. So write the numbers in clear spaces, which I'll show it to you. Take one element at a time, go slow and verify the matrix, right? Always do that. Okay, let's get started. Okay, so this is the problem, right? What we need to do is prove that a square minus 8a, or we have to find the value here, or let's assume that we are going with the second problem, that we are going to prove that a square minus 8a is a scalar matrix. Okay, and we know what is a scalar matrix. Okay, all right, so I've taken the number here. I know whatever is in the direction of the x-axis, it's rows, and the direction in the y-axis are columns, right? I know that. So I've taken the matrix. I know that this matrix is a 3 by 3 because there are 3 rows and 3 columns. That's the order of the matrix. I know that also. And I'm going to take the first part among the a square minus 8a. I'm going to take this part first because remember I told you to break it apart and do it slowly, one thing at a time. Okay. So what is a square? A square is nothing but the matrix A multiplied by itself. So I'm going to put it here. So the matrix A is a 3 by 3. This matrix A is a 3 by 3. So the net matrix or the final order of the resultant matrix, which is A square, will be the rows, the outer two numbers, this and this, the rows on the left matrix and the columns on the right matrix, which in this case is same because this matrix is a square matrix where the rows and columns are same. So order of the result matrix is going to be a 3 by 3. I know that. Okay. So how will I solve this problem? There are a couple of ways to solve this problem without doing mistakes, right? So take first things, write down the matrix A square. I've written it 2 times. This is A and this is A, right? And I've told you that this is the row column. This is the final answer. So ignore this for a minute. This is the final answer for the A square, final A square answer, right? This ignore for the minute. I'm going to solve this. So normally what we will do is we'll compute one row at a time, right? So we will take this row. If you remember all the matrix multiplication videos, I'll be taking this row, one row at a time, and take one column at a time, multiply and add the elements, and then go to the next one. That's one way of doing that. If you think that's what you want to do, you can do that. For example, row 1, column 1, and then you compute and put it back, right? If you see 36 here, I put it back. Another way to do that so that you don't do mistakes is like I'll show the same thing. I'll do the same calculation here, right? I'll do the same calculation here. The way I'll do it is I know I'm going to write these 2 spaces. I'm going to take first is I'm going to do all the row computations, right? So I'm going to take row 1 and column 1, then I'm going to take row 1 and column 2, right? So best is I'm going to draw a line here. Best is write 2 matrices like this, okay, without any headache. Draw and take as much space you want in the supplement and the exam answer sheets. Don't worry about the space. If you space it apart and write it away with a lot of space, the readability increases and you will not do mistakes. And I'm going to compute row 1 and column 1, right? Row 1 and column 1. Okay. So on the left matrix, on this matrix, I'm going to just write the row 1, and this matrix I'm going to write the column 1. So what is the row 1? 2, 4, 4. Okay. So I'm going to write 2, 4, 4. And do not write any of the other item. Just leave it blank for now so that there is no confusion in picking up the numbers, because sometimes you might pick up the wrong row or the wrong data element, right? So just write the row of interest. I'm interested in only row 1. I've written only row 1. In this, I'm interested in column 1. I'm going to just take column 1, 2, 4, 4. I'm going to write 2, 4, 4, and remaining just make it dots. Don't worry about that. So now if I just look at this, the computation is very easy. I cannot get lost, right? So I can easily compute. And how I'm going to compute? Equal to, the best way to compute is I know that I need to multiply and add this, right? This and this, right? So write all the rows first. Row multiplication, row multiplication, row element multiplication. Write all the column next to each other. This goes here, this 4 goes here, this 4 goes here, and in between I've left the spaces. Write in big and bold plus sign because you don't want to confuse the multiplication and the plus sign, right? And now it's a matter of simple mathematics, right? This I'm going to write 4 plus 16 plus 16, which will be equal to 36, sorry. And the same, and the first thing you do is take this number, create an empty matrix here, and write down the number here so that this matrix is slowly filled out, right? Now you calculated row 1, column 1. You know that's the first element that goes here. So write down that answer right away after you calculate, and leave the remaining spaces for the future numbers, and slow and steadily compute each one. If you remember, I use the color codes blue, green and orange to calculate that, and after I calculate each number, I'll put it back. So I've got 36, I'll put it back here. Then in the next row 1, column 2, I got answer 32, I'll put it back here. I'll slowly fill this row by row so the matrix is complete. I will use this methodology while spacing out the numbers, not writing anything that is not required, so the multiplication is easy. And while multiplying also, like I said, give the space, write the row, write the column, put in big and bold the plus signs so that the plus signs and multiplication are not confusing, and do not make any mistakes. So you can write each element like that one by one. The blue ones are the row 1, the greens one are the row 2. I've calculated each one. If you see, When I compute row 2 and column 1, I'm just taking row 2 and column 1 which I'm interested, and remaining I'm leaving it as blank, multiplying it nicely, getting the final answer, and immediately going back and putting it in the green column one by one thing at a time, right? Like that, eventually I'll get all the 9 elements and I'll put it here in this format. So I got all the 9 elements. So this completes the computation of a square itself. Now I have the remaining piece because I need to do a square minus 8a, right? So I need to take the 8a part. So here is the 8a part. I'm taking 8, which is kind of a scalar. If you remember, it's not a scalar matrix yet, but if it's just a number without the matrix, so it's still going to behave as a scalar number. So a number which is 8, which is scalar, multiplied by the a matrix. And if I just do a simple multiplication, this is the number I'll get. I'll just take 8 and apply it, multiplied by each of the elements. I'll get this number. And this kind of the scaled up version of the matrix. If you remember, this matrix is scaled up. It's transformed or scaled up 8 times in the dimension, wherever it's a 3-dimensional, right? Because it's a XYZ 3x3 plane, right? So that's what it means if you apply the transformation concept. The matrix, the number on the left transforms the matrix on the right, scales up by a unit of factor of 8, and this is a scaled up matrix. Now coming back, put in both the matrices. You have the a square, which I computed with the long computation. There's a minus sign, and I'm going to put 8a here, right? And if you remember, right, as you compute this a square also, or even the 8a, you will see the pattern because the diagonal elements are coming the same. So you know that you're on the right track to start with, because if you have to prove that this is a scalar matrix, you know the diagonals have to come right. So as soon as you are missing on one of these, you can check then and there itself that something is wrong. I need to get the same answers over here, and the same way over here, right? The diagonals are the same. So there is the hint that you're going on the right track. And when you kind of subtract that, you are obviously going to get the right answer where the diagonals are same and the non-diagonal elements are 0, and hence it is a scalar matrix, right? Which means that if you're going to use this matrix on the left side on any input other matrix on the right side, so let's say this is your scalar matrix from here and this is your input matrix, the transformation effect the left has on the right is going to be a scalar where that matrix is going to be scaled up by a factor of 20. In this case, this is a scalar matrix. In this case over here, it's a scalar number. The effect is going to be the same, but the matrix multiplication will change on how you do that, right? So pretty much that's it on this video. That's as simple as that. So pick up the problem in the right format, space it out nicely, write only what is required. Don't confuse and pick up the wrong rows and the wrong columns, and make sure that as you fill your boxes and as you approach your answers very well on the way, you know that it's a scalar matrix. The number should add up. If don't try to keep on computing without noticing the number. There is a pattern coming here. If you don't find it, fix then and there itself, and then you can secure your 4 marks on this problem. If it was this problem, I think you have to just trust your luck that you're not made a mistake. That's why I try to avoid this. But in this case, since the answer is given, you can secure your 4 marks because it's a scalar matrix. There is no other way to go about that. You cannot go wrong. Even if you go wrong, you can fix it, guys. So that's your 4 marks coming straight up, guys. Let's talk more on the next video on the remaining set of problems. Whatever is left over here, we'll talk about that. Stay tuned. Coming up next videos on multiplication and addition, type 1 and type 2.